In this video, I will be showing you guys what actions you can take to discover, analyze, and to mitigate malicious entities or potential viruses in your Linux system. In situations where you believe that your system has been compromised and you've confirmed this objectively, then I would always recommend you wipe your system clean and reinstall from scratch. Today though, I will be showing you a set of tools and programs you can use to detect and mollify any potential threats. The first thing we can do is use the inbuilt functions available in our package managers. Pacman has a special flag. If you specify the option key twice, it will perform a detailed form of checking. It checks the permission, file size, and modification time. Here we can see that it will list out any altered files, and we can perform the necessary actions when we find a file out of place. As seen here, most of the packages I installed when I set up the system result in 0 altered files. We can see that all the libraries, Firefox, and several of my kernel files are not altered or changed. We can also see that the firmware is not altered too. In my case, I see only things that are normally supposed to be different, and some I changed myself. The mismatches in fs tab and the password file and the etc directory is also completely typical. To help you understand this aspect, take into consideration the /etc/password file. This file contains information on login names and passwords of users. The file that gets included in the file system package is just a template. This would lead to a discrepancy, as your own passwd file would have your passwords and login information. The whole process does not take very long, only a couple of seconds. If you wish to go through the output more comfortably, then you can pipe the results to less. You can scroll using J and K and pause the output as well. What should be noted is that when there are file mismatches or alterations, it may likely not be malevolent. It may be an inconsistency in relation to the timestamp associated with the file, or a corruption caused to the file or the package. The next method to detect malicious activity is using the Paccheck program to validate SHA-256 signatures of the installed packages. To use it, you first need to install it. It is part of the Pacutils package. Then simply run the command to begin checking the packages. The only real issues it found is regarding the SD terminal. I made the changes myself to this particular package, so this is expected. Next, we will be installing an application called Clam Anti. This is an open source cross-platform antivirus toolkit. It is an advanced tool for scanning files provided by its command line scanner and an automated database updater. Even if you're on Linux, it can still detect Windows viruses too. You will first need to install the package. Then at your first run, you will need to use the command called freshclam. After that, you would need to start and enable the service. You have two options. The first one will make Clam Anti check for updates to the database every 2 hours. You would first need to start it like this, and display start with enable after for it to run at every boot. If you want a service to check for updates only once a day, then you would need to run this command instead. Okay, I'll make an empty file and I will scan it. To show you how to scan a single file, just type clam scan and then the name of the file. It assessed the file correctly and it did label it accurately. If you want to scan a program, say for example the SD terminal, then run the same command but point it at the binary. Again, the scan completed and it did not find any issues with the application. If you don't want to wait for it to load and compile the signature every time, then you would need to enable the daemon service. Simply run the following command. Now if I try to scan my entire home folder, it will not need to load the signatures anymore. Please observe that when you do run it as a daemon, it will take up a lot of space in your primary memory, and it will take even more memory when it updates. I would suggest you not to run it as a daemon other than for using it occasionally to scan for viruses. When it finishes scanning, it will again give us a brief summary of completion and we can go through the results. Moving on to the next program, we have our K-Hunter. Our K-Hunter or Rootkit Hunter is a security monitoring tool for POSIX compliance systems. It scans your system for rootkit as well as other possible vulnerabilities. It does this by scanning the default directories used by the rootkits, along with misconfigured permissions, hidden files, kernel modules containing suspicious strings, and it then compares these with known good hashes. Before we can use the program, we would first need to run the following command. This will update the properties of the database. Next, we would probably want to update the data files as well. To actually use our KHunter, we would need to run the subsequent command. First, it will begin checking the strings. As this is running, we can see a few warnings regarding fgrep and LDD. This is normal for Arch Linux as some of the core utilities have been replaced by scripts, so you do not need to worry about the warning for these packages. You may also get warning for egrep as well as get. These are false positives and can be whitelisted in the configuration file. It finished the string check and it did not come up with any other warnings. It's now performing the check for rootkits. For those who may not know, rootkits are a collection of complex malicious code that are used to gain unauthorized access and perpetual control over a system. Rootkits come in various forms. They can be either kernel-level rootkits, application-level rootkits, or rootkits that use shared library or objects. An example of such a program is the Jellyfish rootkit that was published on GitHub. This rootkit was first designed as a proof of concept to show that malware can run on GPU, allowing it to run virtually undetected. Rootkits, if they are able to gain access, are indeed quite terrifying. This danger stems from the fact of how covertly they can run and also at how much damage they can inflict. Additional checks are also made if there are any login backdoors in your system, if a log sniffer is present on your machine, as well as any weird shared memory segments or directories. Then it's gonna move on to kernel modules as well. Everything seems to be fine here too for me. In the groups and accounts check, it flags changes to password as well as the groups file. This is totally normal and is nothing to be concerned about. It also finds hidden directories. This is also a typical thing to see as in Linux. Any directory starting with the period is hidden. I have a lot of hidden directories on my system, for example, the .config directory where the configuration files for my programs are installed. So this is nothing to be alarmed about. Finally, after 2 minutes and 27 seconds, the scan is complete. The 3 suspected files are not actually dangerous and are typical false positives. Regarding the rootkits, none of them were detected on my OS, so that is good. The next program I want to show you is Lynis. Though not necessarily like the other tools to detect viruses, the auditing it performs can help us detect any anomalies we may encounter. Lynis is an auditing tool for systems based on Unix. The tool checks the system and the software configuration to see if there is any room for improvement or changes required. The first thing you would need to do is install it. After that, run Lynis, audit system. It will first generate basic information about your environment, things like your operating system, kernel version, and it will also specify where the log files will be stored. The next thing it does is that it scans boot and service options. The tool lists out the fact that I run systemd with grub installed. It also highlights the fact that I don't have a grub password on this machine. Furthermore, it performs a systemd analysis on the security of the systemd services I have running. You can always rewrite the services yourself and test them out, but that will exceed the scope of this video. Though not something you should be that worried about, they can obviously be tweaked to be more secure. The tool then moves on to checking the kernel for any sign of weaknesses. Here it does not find any issues with my system. Neither does it find any issues with regards to memory and processes, nor does it find any real issues with users and groups. I don't really see any problems with shells and file systems either. In the USB devices segment, it does suggest we install USB Guard. USB Guard provides a way to whitelist or blacklist certain mechanism of USB devices. It leans on several Linux kernel features to do this. In Arch Linux, it is very easy to install as it is a single package. In the next segment, it also found the fact that I am running a firewall too. If you had any SSH or SNMP daemons, it would mention them here. Another thing I want to highlight is Security Frameworks section. If you really want to secure your system, though not usually that crucial, it would always be a good idea to install something like AppArmor or SE Linux. AppArmor is a mandatory access control system that protects the operating system by enforcing a specific set of rules for applications. It can protect against internal and external threats as well as in certain cases prevent 0 days from being used. In the kernel hardening section, it does provide us with a lot of warnings or differences as it labels them here. These kernel settings are usually not enabled for the vanilla Arch kernel, but if you use the hardened kernel, most of the defaults are set to be more secure. After it finished, it will spit out a data report and a log file for us to go through it if we want. This has been my video showing you how to check if your system has been compromised. Please know that these tools are not the magic bullet that discovers all viruses or malevolent code, but they do provide ways to check if there is actual malicious activity happening on your Linux OS. Thank you so much for taking the time to watch my video. If you found it pleasant and informative, please do leave a like and subscribe.